We're going to graph some conic sections. We're also going to write equations of conic sections, and we're going to start with a circle. So a circle in standard form is x minus h squared plus y minus k squared. That h is the horizontal shift, so how far it's shifted left or right of the origin, and k is the vertical shift, how far it is shifted up or down from the origin. And that r is your radius, which is also the stretch. In a circle, a horizontal stretch and a vertical stretch, or a dilation, is the same. Horizontal and vertical stretch is exactly the same, which is what makes it a circle. And I'll show you later in the equation how that actually represents both different stretches. Okay, so we are going to write an equation for a circle with its center at 7, negative 11, and a radius of 9. So 7 is the x value, that's the horizontal shift. It's shifted 7 to the right. And the equation is x minus h, so the opposite of that number. So there's our h, we've got x minus 7 squared, plus y minus k, and k there is negative 11, so it'll be y plus 11 squared. So it's the opposite that goes in both of these spots, the opposite of x and y. Okay? So our center is hk, and what goes here is the opposite of those. And then the radius is 9, r squared, 9 squared is 81. Okay, so here we've got x plus or minus 0 squared, which is just the same as x squared, plus y, and then I've got a negative 15, so plus 15 squared, equals, and then the square root of 17 squared is 17. Okay, now we're going to graph a couple of circles. Okay, so here we've got a circle, x minus 3 squared. That means the x value is going to be 3, y plus 1 squared. The y value is going to be negative 1, so the center is at 3, negative 1. So 3, negative 1 is right there. So there's my center. R squared is 5 squared, so that means the radius is 5. So I'm going to put a point 5 to the right and left of the center and above and below the center. And I'm going to do my best to make a circle out of that. I went a little bit past where I should have, but that gives a pretty good idea of where that circle is. Okay, so here we've got a center at negative 2, positive 5, and the radius is the square root of this number here because that's r squared. The radius is 3, so negative 2, positive 5 is my center, and 3 in all 4 directions from there. I went a little fast again. I'm going to try to fix it. That's a little better. Okay, and here we've got a center of 4, 2, and the radius is the square root of 12. And if you type the square root of 12 in your calculator, you're going to get about 3.46, about 3.5. So over 4 up 2, and a radius of right about 3.5. So about like that. All right, so a circle is x minus h squared plus y minus k squared equals r squared. If I divide both sides by r squared, I get x minus h squared plus y minus k squared over r squared equals 1, which is the same as x minus h squared over r squared plus y minus k squared over r squared equals 1. In my vertical component and my horizontal component, I have the same stretch. So the horizontal dilation and the vertical dilation are exactly the same, and that is what makes it a circle. Okay, so same stretch is what makes this thing equal a circle.